Hi, once again, welcome to this series of video tutorial intended for grade 9 chemistry. This is Sir Edwin, the Division Science Coordinator and the Principal of Francisco Benitez Elementary School, Maine. So, this lesson is divided into three parts. So today, in this video, I will be discussing the first part. Okay, but before we go to the main lesson, let's have a short recap once again to the content of the previous video tutorial. So in the previous tutorial, you learned about how to compute the percentage composition of certain element in a given compound. Okay, so based on the mathematical equation, the percent by mass of the element can be calculated by this mathematical formula where the mass of the element is divided by the formula mass of the compound, and we will multiply the quotient into 100%. Okay, since we are looking after the percent by mass. So when you say mass of the element, once again, it is simply refers to the atomic mass of the element, or the sum of atomic masses of that element that is present in a given compound. While the formula mass is simply the molar or the molecular mass of the compound expressed in grams, and the 100 is used as the multiplier in order to convert the quotient of the mass of the element and the formula mass of the compound, and to arrive with the percent by mass of that particular element. Alright, so last lesson, we uh, compute the percent composition from a chemical formula. So the given is actually a chemical formula, and from that, we're going to compute or calculate the percent composition of each element present. But in this particular lesson, okay, we're going to compute, or we're going to find out the chemical formula of a certain compound based on the given percent composition. But again, for this video tutorial, what we're going to discuss for the meantime is about the general types of chemical formula. So, generally speaking, when we say chemical formula, it has two types. So, the first type is the empirical formula, okay, and the second type is the molecular formula. There are other types of chemical formula, but in this lesson, we will be discussing, our discussion is only limited to empirical and molecular formula. Okay? Okay. What do we mean by empirical formula? Okay, this is defined as the simplest formula of a certain compound. Okay, so it's the simplest because it gives the correct ratio of atoms in a molecule. But take note, it does not necessarily the correct formula. So, what do we mean by this? Suppose you have a cake, the cake during your birthday, as we used in the previous video tutorial. You divided that uh, into 16 equal parts, and for example, out of the 16 parts, you distribute 8 parts of that cake into your visitors. Okay, so it means that 8 out of 16, 8 of that 16 was distributed, or were distributed rather, to the visitors. Okay, but if we are talking about the simplest or the correct ratio of the cake being distributed, we can say that one half of the cake was distributed to the visitors. So there's a big difference. There's a difference between 8 over 16 and 1 over 2. Okay, that 1 over 2 is the simplest ratio. That is also called in chemical formula in chemistry, we call that as the simplest formula. It does not tell us the actual number of the atoms, just like the cake. When you say one half of the cake, it does not mean that the cake is divided into two and only one part of that cake uh, is given to the visitor. But in actual, 8 parts of the cake were distributed out of the 16 parts. Okay, so that is basically the definition of an empirical formula. Okay, I have an example here. Let's take a look at the molecular formula of glucose is C6H12O6. It means that in one molecule of this sugar or glucose, it has 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. But its simplest or empirical formula is CH2O. Okay, so how do we arrive with the simplest formula, the CH2O, from its molecular formula C6H12O6? Okay, so to illustrate that, okay, once again, this is the formula of the glucose. Okay, we're going to look at the subscripts 6, 12, and 6. No, how do we reduce that into simplest formula? First, this 6 is what we call the greatest common factor of the subscripts. So basically in mathematics, how do you find the greatest common factor of numbers? So from 6, 12, and 6, the greatest common factor is 6. So what will you do to this greatest common factor? Okay, you divide. Okay, use this as the divisor of the subscript. So C6 divided by 6 will give you C1. Of course, 1 as a subscript does not need to write here because the symbol itself of the element correspond to one atom. So H12 divided by 6 will give you H2, and O6 divided by 6 will give you O. Okay, hence this is now what we call the empirical or the simplest formula of the glucose, which is also called the blood sugar, okay, or the grape sugar. Okay, so take note once again that this CH2O does not contain the actual number of atoms present in the molecule, because when we talk about the actual number of the atoms in a given glucose molecule, it consists of 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Alright, let's go to the next. What about the molecular formula? So when we say molecular formula, it gives the correct or true formula of a molecular compound. So it was not simplified. The subscript the subscripts were not simplified. Okay, because it should not be simplified because these are the subscripts tells us the actual number or the correct number or the true number of atoms present in a given molecular formula. Okay, once again, we will be using the glucose, the C6H12O6. So this is an example of a molecular formula. Okay. Okay. Take note, my dear students, that the molecular formula of a compound is sometimes its empirical formula. Okay. What do we mean by this? So there are chemical formula that is already considered its molecular formula at the same time empirical formula of that compound. Okay. Now, to determine to sum up our concepts with regard to the empirical and molecular formula of compounds, let's do these exercises. This exercise, the question is, which of the following molecular formula are also empirical formula? So let's take a look at number 1. This is our table sugar, the sucrose, having a chemical formula of C12H22O11, or commonly known as the table sugar. So if you're going to look at the subscript, okay, in order to find out whether a certain formula is already a molecular or an empirical, is to find out if there is a greatest common factor among or between the subscripts of elements within the formula. So, seeing these subscripts, okay, 12 for carbon, 22 for hydrogen, and 11 for oxygen. I think, okay, the only common factor among the three subscript is 1. So in other words, of course, 1 is a factor of all numbers. So there is no common factor between or among 12, 22, and 11 subscripts. So in other words, we cannot simplify this. We cannot simplify this. So sucrose is C12H22O11 is what? Both considered both molecular and empirical formula. Okay? What about number 2? Of course, the chlorophyll, which is very essential in the food manufacturing of the plants, which is called the photosynthesis, has the chemical formula of C55, H72, Mg, and 4O5. Again, going back, look at the subscripts and think of the common factor or greatest common factor among the subscripts. But looking at the subscript, there is no common factor aside from 1, which means that this formula of chlorophyll is considered a molecular, at the same time an empirical formula. Okay, let's go to the third example. Of course, you are very familiar with water, which is considered as the universal solvent. So what are the subscripts? So 2 for hydrogen and no subscript for oxygen. So again, the subscript is 2 and 1, which is invisible because the oxygen symbol itself represents 1. So there is no common factor. Therefore, H2O for water is considered molecular and empirical formula. Number 4, we have the ethane gas having a chemical formula of C2H6, which is considered one of the gases in our liquefied petroleum gas. Now, what are the subscripts? 2 and 6. So, based on the subscripts, can you think of any common factor aside from 1? Alright, so the common factor is 1 and 2. Therefore, between 1 and 2, 2 is greater. So, therefore, that greater common factor between 2 and 6 is 2. So, again, you're going to divide. So, C2 divided by 2 will give you C, and H6 divided by 2 is equal to 3. So, what is the empirical formula? So, it should be CH3. But in terms of the question, C2H6 is considered a molecular formula only. Okay, did you get that? Alright. Now, okay, let's have another activity. Okay, write the empirical formula of the following compounds. So these are the compounds. There are 6 compounds. So basically, what are you going to consider in determining the empirical formula? You're going to consider the subscripts present. So between 2 and 4, okay, what is the greatest common factor? It's 2, right? So N2 divided by 2 will give you N, and 4 divided by 2 will give you O2. So the empirical formula is NO2. Now, CO2, So there is no common factor aside from 1. Therefore, this molecular formula is also considered its empirical formula. Next, number 3, this is the H2O2, or this is known as the hydrogen peroxide. So it's very obvious that the subscript uh, between the subscripts of the two elements are the same. So both two subscript. So the uh, common factor is 2. Of course, H2 divided by 2 is H1, or O2 divided by 2 is O1. Of course, 1 should not be written as subscript. The C2H4, this is what we call the ethene gas. Okay, so the greatest or common factor between 2 and 4 is 2. Therefore, the empirical formula is CH2. Okay, let's go to number 5. The ferrous sulfate, or the iron 2 sulfate, there is only one subscript. Therefore, there is no common factor. It means that this formula rather, is also considered the empirical formula. Okay. Number 6 is the C12H22O4. Alright. Looking at the subscripts 12, 22, and 4. What do you think is the greatest common factor? Of course, the greatest common factor is 2. So C12 uh, uh, divided by 2 will give you C6. H22 divided by 2 will give you 11. And O4 divided by 2 is O2. So that is, or these are the empirical formula of the given molecular compounds. Okay? So let's have the summary of concepts. So again, there are two types of chemical formula, the empirical formula and the molecular formula. So when you say empirical, it's the simplest formula but does not give the correct or the actual number of atoms in a given molecule. On the other hand, molecular formula gives the correct or true formula of molecular compound, and the molecular formula of a compound is sometimes its empirical formula. So I hope you learned something in this video tutorial, and in the next video tutorial, your knowledge in this particular lesson is very much needed for you to understand. So once again, good day and happy learning, and thank you for watching.